Hi guys, in this video we are going to learn what's meant by the gauge pressure and absolute pressure, and we are going to do a sum regarding that. If you are new to the expert tutor channel, please don't forget to subscribe it. Also, here I've done many videos regarding fluid mechanics and fundamentals of engineering. If you like to watch them, I have given the link in the description, so you can always watch that. Okay, without wasting our time, let's move to the main part. So over here actually you can see that there is a container which is having a gas of pressure A, and there's an oil after that which having a relative density of 0.65, and the height of that is 100 centimeter, and after that there's a water in it. And for measuring the pressure of that PA, there is a setup over here. So for that they have connected a manometer over here, so you can actually find the reading of that it's going to be 10 centimeter height difference between these two levels of mercury. And they have told that there is an open tube and they have given some length and height. So the question is, first of all we need to find what's the gauge pressure of this gas, and after that we need to find the absolute pressure of that gas. So what's meant by the gauge pressure is, when we are considering about the normal things, let's say you are on Earth, actually you knew that you are going to have a pressure from that atmosphere around us. We are going to have a pressure in us, in our body, because of the atmosphere. Actually it's same for everything in the Earth. Normally if we are in the same level, we are going to have the same pressure, which is for the standard pressure is 10 to the power 5 10 to the power 5 Newton meter minus 2. So the thing is, 10 to the power 5 Pascal, okay. So the thing is whether it's going to change in a same level. Let's say you are having a pen and a pencil in your hands. Let's say I'm going to have these two. These two objects are going to have the same atmospheric pressure because they are in the same level. So from that, when you are considering about any nature, it's enough to neglect that atmospheric pressure when you are doing the sums, because they are in the same level. So actually we don't need to consider about the atmospheric pressure. So what we are going to do is, we are going to take that there is no atmospheric pressure and we are going to do the sum. If you do so, we are going to tell it like gauge pressure, because it's going to be the same in the same level for every object. It's going to be the same. So there is no use of finding that or calculating that or adding that to that calculation. So we are going to remove that and we are going to take it like 0 relative to that atmospheric pressure, which means we are going to take it like 0 atmospheric pressure and going to do the sum. That's known as gauge pressure. If you find that of any pressure inside this one with relative to that atmospheric pressure, if you consider the atmospheric pressure as 0 and find this one, you are going to tell it like gauge pressure. If you consider that atmospheric pressure and find this value, you are going to tell like absolute pressure, which means it's the real pressure inside this. But for the calculation, for the needs, we don't need to find the absolute pressure of this gas. Actually it's enough to have the gauge pressure and figure it out. So that's the simple thing. The both are similar, but the thing is, we are going to neglect, or when you are considering about any pressure, we are going to take relative to atmospheric pressure, but absolute pressure is going to give this real pressure inside that. Okay, let's move to the question. So if you have understood this idea clearly, please pause the video and try to figure it out, the gauge pressure and the absolute pressure of this gas, and after that compare my answer with yours. Okay, without wasting our time, I hope you have already done that. Okay, let's try to do it. So here, when you are considering about this question, actually we knew that when you are considering about the gauge pressure, I have already mentioned, when we are considering about the atmospheric pressure, we have connected this manometer to atmosphere. Actually we knew that there is going to be a pressure of 10 to the power 5 Pascal, but we are going to take it as 0, because I have already mentioned that when you are considering about the atmospheric pressure, the gauge pressure, we are going to take the atmospheric as 0 relative to that. So we can take it like 0. So what we are going to do is, actually we knew that when we are considering about the same liquid, it's going to have the same pressure in the same height. If there is a same liquid, that's the rule. If there is a same liquid in a rest, you can actually take that in the same height, which is actually, you can see that they are in the same height. If they are in the same height, you can tell the pressure on its two sides are going to be equal. In this position and this position, the pressure in these two are equal if they are in the same liquid. It's the same liquid, which is mercury. So we are going to equate these two pressure and going to get the answer. Okay, let's move to this one. So there's a pressure PA, which means it's going to pressurize this oil using this PA. So the actual reason is why we are going to take this part is we are going to find the pressure in this side, the mercury, and after that we are going to find the pressure in this side and we are going to equate that. So first of all we are going to find this part. So for that we are going to take whole the thing, because it's starting from this container is fully closed, so we can tell this one is going to have pressurized the things first. So we can tell it's going to pressurize this oil by this pressure A. We need to find that. The oil is going to pressure we have already pressured that oil. The oil is going to pressurize again the water, which means the water would realize the pressure of oil and the PA, the pressure of gas. So when we are considering about the oil, which is having the relative density of 0.65, actually we knew that when there's a liquid, we can tell, not only liquid, we can directly tell if there is a fluid also, we can use that H rho G. So when we are considering about the H rho G, actually we knew that it's going to have the H, the height of this oil, which is making the pressure in that water, is going to be, actually you can find it out, it's going to be 100. 0.1 meter. So the next part is we are going to take the rho, the density of this oil, we need to mark it out like this. So the oil's density would be 0.65, the relative density into 10 cube into its gravitational acceleration, which is 9.81. So this is the pressure made by this oil. And after that we are going to consider about the water. When you are considering about this point, the pressure in this point is going to caused by the pressure of A, the pressure of gas. It's going to move that pressure, that oil, and oil is going to pressure that water, and water is going to pressure this point. So when you are considering about this, actually we need to figure it out what's the length of that. When you are considering about that, when you are considering about this water, it's going to have the height from this part. Let's say if you mark like this, we need to figure it out what's the height of this. So after that only we can figure it out the answer, because when you are considering about that, it doesn't mean you don't need to consider about the shape when you are considering about the pressure in a fluid. So when you are considering about this, actually some might think it's not the same, it's not like the same, it's having a very big area and it's going to have a small area. Why we need to find the H rho G? When you are using the H rho G, why we are using this part H like this? We need to find this part for individually, and because the area is higher, and after that we need to figure it out the answer for this H rho G, because this area is smaller. The thing is, remember, when you are considering about the pressure from a fluid, actually you can directly use the H rho G, whether because in any shape, because it doesn't actually depends on that shape or on that area, so you can directly use that. So we need to find what's the height of this. Can you find that over here? Most probably most of you have already figured it out. It's going to be, actually we can tell this H plus this 100 is going to be equal to 175 plus 10, because these are the same heights. So from that we can tell it's going to be 185, so H is going to be 85 centimeter. Have you figured it out? This is a little bit trickier part over here. So after that we are going to add that part too. So when we are adding that, it's going to be pressure of water is going to be H, which is 0.85, and the rho is the density would be 10 cube into G 9.85. So this whole part is the pressure made on this mercury. gas is also going to make the pressure, oil is going to make the pressure, and water is going to make the pressure. The total pressure is going to act in this point. Okay, let's move to the next part, this point. What's mean by this point? What is making the pressure over here? Actually, we mean that it's going to make the atmosphere is going to make the pressure, and the mercury is going to make the pressure. But the thing is, we are going to take the atmospheric pressure as 0, so we are only having this part only, which is 10 centimeter of mercury. So actually we knew that it's going to be equals to, so I'm going to write over here, it's going to be equals to the height of that is 0.1 meter into, I think I have made a mistake there, it's going to be 1 because it's 100 centimeter and 0.8, yes, 0.1 into 10 to the power cube into 13.6, which is going to give the density of the mercury into 9.81. Okay, now we have get that equation. Now we need to solve that. Actually we can figure it out. There is 10 to the power cube in these three, and let's subject that. If you subject that, there is 9.812. So I'm going to take the 10 cube into 9.81 into common. If I take that, it's going to be 1.36. If I bring that to right side, it's going to be 0.85 minus, if I take this part, it's going to be 0.65. Yes, now we are fine with that. So we need to solve this. So I'm going to use the calc over here. 1.36 minus 0.85 minus 0.65, which is giving the answer of minus 0.14 for this part. This is minus 0.14, and we need to multiply by 9.81. So 9.81, which is going to give minus 1.3734. If we multiply by 10 cube, it's going to be 1373.4, but it's going to have a minus sign. What's mean by that? The thing is, actually we are now finding the pressure relative to that atmospheric pressure. So what we can tell that is, according to the atmosphere, if you compare the pressure of this gas with relative to that atmospheric pressure, we can tell that the gas pressure is going to be lower than that atmospheric pressure. That's why we are going to get that as minus 1373. The thing is, actually the absolute pressure cannot be 0. That's the thing. But the absolute pressure can be 0, but actually absolute pressure cannot be take the negative side. But here we have taken the gauge pressure, which means relative that atmospheric pressure, it's going to have the negative side. Actually we are taking that atmospheric pressure is 0. Relative to that, the pressure of this area, so pressure of this gas is going to be lower. Hope you have understood that clearly. So this is gauge pressure. So how we can take this or change this for the absolute pressure to find how to find that using the absolute pressure is, actually we knew that when you are considering about the absolute pressure, it's going to be sum of the gauge pressure plus the atmospheric pressure 10 to the power 5 Pascal. Actually we knew that, and we are going to add this part minus 4 Pascal with this part. Why are we adding that? The reason behind that is, actually we knew that it's going to be lower than this part. So actually when you solve this, you are going to get lower than this 10 to the power 5 Pascal. If I do that, 10 to the power 5, or in other terms I can write 1 2 3 4 5. Okay, and I'm going to deduct 1373.4. if I do so, I'm going to get 98626.6 Pascal. So this is the absolute pressure, the real pressure in it. But the thing is, when you are considering relative to absolute atmospheric pressure, you are going to get in negative sign. Some might have the doubt whether we can use, when you are finding the absolute pressure, we can equate this whole thing with the 10 to the power 5 Pascal. When you are equating this in the first gauge pressure, when you are finding the gauge pressure, we have neglect this 0 and write this equation. However, when you are considering about the absolute pressure, actually you can do that and try it on your own. You can take this as 10 to the power 5 Pascal in this side over this mercury, it's going to have the atmosphere is going to make the 10 to the power 5 Pascal, and after that you can make this sum, make this equation like this equation, and solve that. You are going to get this answer. If you like that, please try it in your own. I hope this video would be useful for you, and if you have any doubts, please comment it below. Thank you for watching.